Hello everyone. Welcome back to the class. How are you all? How's going on? Have you watched the last two videos which we have discussed about the acids and bases and their properties? Have you done that? Uh, I hope you all have watched that video. So students, now in today's session, what we are going to do is we are going to start a new topic which we called as the equilibrium. Actually, student, this topic is very new to you because this is not a part of the syllabus, but it will come in Olympiads and in the JEE level. So that's how it will be an advanced topic for you. Like for example, if we talk about acids and bases, okay. So students, like in acid and bases, you have read about acid and bases from your class 8 or class 7th, but now if we talk about the equilibrium, it is the very new thing about for you. Okay, so it's my request to please look at this video with a great attention, so you'll come to know that what's the equilibrium is exactly. Fine. So like student, if I talk about starting with the equilibrium, that what's the equilibrium, so from the word only, that is the equilibrium, if we see that the equilibrium word is have a meaning in itself. Okay, if I ask you what do you understand by the equilibrium, so equilibrium will have its own meaning. Like you know that the equilibrium words come from the equal word, and you know what's the equal means. Equal means when two things are just similar to each other, then we say it as a equal thing. Okay, for example student, like if I give you one example here to make you understand what's the equilibrium is. Okay, there is one boy. Okay, and that boy is having one box. Fine. And in that box, what he is having 8 balls. Okay, he is having these 8 balls in one box. Now if I say this one boy is he is a boy and he is having one friend of his. Okay, a very good friend of his. Now this friend want to take these balls from him, but so what the thing is that now he is having his box. Now what the thing is that now this boy transferred 2 of the balls here. Okay, 2 balls he has transferred here initially. Fine. But now this friend asked him, that means in this condition, how many balls he is having right now here, students? It will have only 6 of the balls. Exactly when he has given his 2 balls to his friend. So now what will the condition that it will having only 6 balls? Fine. But now his friend, like this friend was a very good friend of him. So he can fight with him. He can demand like he can put his demand in front of him. So what he was demanding, that he was saying that I want equal number of balls from you. So what he did, that because he is a very good friend of him and he liked him so much, so what he did, that he transferred the 2 balls more to his box, like means 2 balls are all transferred here. So what the condition now, that means these 2 balls have been removed from here. So you can see that in the in the first box, if I consider it as the first box, and if I consider it as the second box, so you can see that both of the friends are having equal number of balls. But initially when they have started talking to each other, so what we have noticed, that one boy is having the 8 balls, the another one is having no balls. That means initially we don't have anything that point. Fine. But when they start talking to each other, so what's the point, when the second friend asks to his friend that okay, give me some of the balls, so he gave him 2 balls, but he was like, no, I want the equal one. So that's how he gave him the equal number of bowls. So now they both are having the equal number of bowls in their boxes. So that's how this condition will called as the equilibrium condition. Equilibrium condition means when they are having equal number of things, for example balls or something like that, that is called as the equilibrium. I hope you got this point. For example, if I tell you that okay, in your house, if you are having your younger sister or the younger brother or like that, you are having your siblings. So if anything comes to your house, if for example your father is bringing you chocolates, so what he'll do, that he'll bring one chocolate to both of you, or it's like that he will bring two for each of you. Exactly, he will bring equal number so that you won't have any fight between. So like he will always maintain the equilibrium between the siblings. So that's how that is the condition of the equilibrium. Now students, we have to read this equilibrium in our chemistry subject, that how we see the chemistry here. So students, like, you can consider, you can take this example. Initially he was having the 8 balls. Okay, so please try to understand what I want to make you understand here. It is okay, just try to see. You can consider the initial condition when he was having the 8 balls. For example, students, you know that in the reaction what we require reactant, which is converting into the product. Okay, so initially when we are having two reactants, for example A and B reacting with each other, so initially for example that like the boy was having 8 balls, so we are having only reactant initially, that we are having A and B only. That means they both are not reacting with each other. That means at that point of time we don't have any product. Now when after the some time when they are reacting with each other, so some point will come when they will form the product, and and these two are equilibrium with each other. For example, if at this side there is the 5 gram, so at this side there will be also the 5 gram. If there is 10 grams, so there is also the 10-gram formation. So that condition is called as the equilibrium condition in terms of chemistry. Fine, so we can say that when the if we talk about the mass, or if we talk about generally when we talk about the equilibrium, so we talk about concentration. Student, now you'll say, ma'am, what's the concentration? It's just that the amount of that particular reactant or product present in a particular amount of volume, that we call it as its concentration. For example, if you have seen the molarity, that what's the molarity is, student? So the molarity is number of moles divided by the volume, so that's the concentration. So exactly when the concentration of the reactant and product equal to each other at one point, then we called it as the equilibrium. Okay, that is called as the equilibrium. So similarly, when we have taken the example of two friends, so initially that boy is having the 8 balls, but after some time what we have seen, that he has given his 4 balls to his other friends, and the initial one is having 4. Now both are having four balls. That means they both are at equilibrium with each other. And similarly in the terms of chemistry, if we see, so the point will come when we are having the equilibrium in our reactions as well. Okay, so that's how we see the equilibrium in terms of chemistry. Fine. Now, if I take one example of reaction only, that you'll say that, ma'am, please take any reaction, name of any reaction, that how we come to know whether it is the equilibrium or not, or how the reaction is proceeding. So, okay, we'll take one our example. For example, students, that initially when we want to prepare something, so we'll take its resource. That okay, we'll find out their resource. That okay, from what thing we can prepare it. For example, okay, we'll take one daily life example only, that once like if our mother wants to prepare a roti or chapati, so what she'll do, that first of all she'll take the flour, but at the time of flour there is no chapati, but after some time you'll get the product. So that's how you can say that the flour is the reactant and the product is the chapati. So the same thing will the reaction also, that if we want to convert that that is if we want to do one reaction, for example, this is the very famous reaction, that the calcium oxide reacting with carbon dioxide and forming the calcium carbonate. That means if initially we are having calcium oxide and carbon dioxide, so we are having only this, but when they react with each other, after some time we'll get the product, that's the calcium carbonate. So that's the reason. And at one point the concentration of both the side, like reactant side and the product side, will be equal to each other, and that condition it's called as the equilibrium condition. I hope you got the concept of equilibrium, that what exactly the equilibrium is. Fine, students? Okay. Now moving towards this topic, that what things we have to discuss here is that okay, first of all, it's that it can be defined a state where both the process take place with equal rate. And if, for example, you can see that reactant and product, reactant will have initially more amount, but after some time it will have less amount. See how you are saying that, if initially I'm taking 10 gram of, okay, I'll give you one example right now here. If I write down this reaction in this format, that is the calcium carbonate converting into calcium oxide plus carbon dioxide. Okay, so initially if I'm taking it as 10 grams, so what happens, student, that initial when the reaction has been started, so initially it is 10 gram, that means they are 0 0 because we are not having any calcium oxide, we don't having any carbon dioxide. Exactly, it is this reaction is which type of reaction, student? If you remember from your first chapter, this is the decomposition reaction. So that means when the decomposition is going on, initially we don't have any calcium oxide or carbon dioxide because we just have taken the like calcium carbonate. But when we start heating it, so what happened after some time, from this 10 gram, it would be 8 gram, and maybe it is coming at 1 gram or 2 gram. After some time, it's like that. If it is 7, so it would be 1.5 or 1.5. And if it is like it would be 5, so somehow at one time will come that when both are at the equilibrium to each other, that it is the 2.5 and 2.5, and we can say that at one point it will come that it will become 0 and they are become equal to each other. That means what happened when the reaction started, so the concentration or the amount of the reactant will be more, but when the reaction completed, the amount of the product will be more, because what we are doing the reaction, and we do reaction to get the product. So that's how initially we just have the more amount of reactant, and then reactant converted into the product by the passage of the time, and that's how the amount of the reactant will decreases and the product will get. Exactly, that's the very well, like, if I want to explain you this thing with this example only. Initially, you can see that this boy is having 8 balls, but when he give the 4 balls to his friend, now he is having less number of balls. That is the four. But if his friend ask him to give more of the balls, so what he'll do? That he'll do that. What he will do? He'll transfer 2 balls again. After again, if he asks again, so he will give his 2 balls again. So that's how the amount of the balls for the first in the first box is going to be decreased, whereas the amount of the balls in the second box is going to be increased by the passage of time and after. So that's how the same condition will be with the reaction, that initially the reaction in the reaction reactant part will be more, but after the completion of the reaction, product part will be more. But between this point, between all of this reaction, there will be some point when we are getting the equal amount of each, and that condition is called as the equilibrium condition. Fine. Okay. Now, students, we are having two types of equilibrium. One is the physical equilibrium and second is the chemical equilibrium. Okay. So, first of all, if we talk about that, what is the physical equilibrium, students? So, physical equilibrium will be C is defined when the equilibrium will develop on like between their different phases or their different physical properties. If I ask you what's the basic difference between the physical and the chemical property, so what it will be? Like because I hope you have heard about that. Okay, all of the things which we are having, they are having both type of the properties, physical as well as the chemical. So what could be the difference between the, like on what basis we say that this is the physical property and this is the chemical property? Think about it. Okay, so I'll tell what's the difference between these two is physical property. If I ask you that what's the physical property of this pen, so you'll say, ma'am, this pen is having cylindrical type of shape. It is black in color, and yeah, it is having this plastic, like it is having a very shiny surface. So, for example, the physical properties are those properties which we conclude on looking at the thing. Like, for example, if you are looking at me, if I ask you that what is the physical appearance of me, you'll say that, ma'am, okay, you are wearing a pink color sweater and something like that. So this is my physical property. Why? Because you can see them clearly. Okay, by observing the properties, which we can say that only by observing, so they are called as the physical properties. But now, if I ask you what's the chemical property of this pen, so the chemical property of this pen is that I can use this pen for the writing purpose. That means this is the actual use of this pen. Exactly. So that is come under the chemical property. So that is how student equilibrium has been divided into two parts. One is the physical equilibrium. Second is the chemical equilibrium. Fine. Now, how we define as the physical equilibrium? First of all, we'll focus over the physical equilibrium. So, my dear students, like for a physical equilibrium, we can define on the basis of their physical phases of properties. For example, like if we talk about water, like in your class ninth, do you like have you studied the chapter states of matter? Obviously everyone has studied it. It was a very nice chapter, even though it's a very easy one chapter, which I have seen throughout my life, one of the easiest chapter throughout my life. It is one of the easiest chapter. It's just that what's the solid, liquid and gas, it's have only that thing. So in that chapter you have seen that there is equilibrium. Oh sorry, equilibrium, not equilibrium, because you are studying equilibrium for the very first time. What you have seen that the water, that we generally use water to explain the states of matter, because water shows three states of matter, like all of the threes: liquid, gaseous, and as well as the solid form. So that's why we take it as the example, because from that we generally learn the three different type of states of matter very easily. So that's how, student, we are going to see that how physical equilibrium helps out, or how we can understand it from concept of the water. Okay, so just give me a minute, I'll show you the example here right now. So first of all, we are going to discuss about the physical equilibrium. Okay, so the physical equilibrium, like I have already told you, that it's about the physical properties, that the equilibrium which we observed over the physical phases, between the physical phases or the properties, that is called as the physical equilibrium. Now, if we talk about water, okay, so my dear students, if you know that the water can exist in three forms, that the water, if it is in liquid, so this can be converted into the vapor form by the boiling process. That means by boiling the water we can get it in the vapor form. And even though we get it in the form of the ice, we get in the form of the ice, that is the solid one, exactly by freezing it. Now why I have drawn these two lines? Because students, it's the state of the equilibrium only. That means there that okay, I'll tell you that why I'm drawing these two, because you can see that we can convert water into the vapors, whereas I can convert vapor into water again. And same condition will be there, that I can convert ice into water and water into ice. For example, if I am having any container and I have poured some water into it, and I kept that container into the refrigerator, so after some time, like after 3 hours, 4 hours, what I will found that there will be the eyes only. And the same condition will be there if I put that container which is containing ice outside the refrigerator for some time. So what I'll see, that ice will convert into the water. So these two are the reversible processes. So that's a, student, the equilibrium would be there, that at one point when the water is converting into the ice, or ice is converting into the water, so you will find at one point that when the amount of the water will be equal to the amount of the ice formed. So that's the physical equilibrium, student. For example, so it would be a solid liquid equilibrium. If I talk about the ice and water equilibrium, so it will, so we'll say it as the solid liquid equilibrium. Solid liquid equilibrium, because there would be a because you can see that if we are taking the ice in or if we are taking water in any container, so it's not like that like suddenly the whole of the water is going to be converted into the ice. It's like that at one point it will start converting into the ice, and that's how we got the container of the ice. And similar thing when we were taking out the ice out of the refrigerator, so it's not like that it, like within a second that whole ice is converting into the water. It's like slowly it will going to convert into the water. So that's how, student, there will be the one point when we are getting the equal amount of both ice as well as the water. So it would be the solid liquid equilibrium. Got my point? And similarly, when we are doing, like if I ask you to take pen and keep some water in it and boil it so that there will be the vapors. So what will happen, student, when the vapors are forming? So you can observe it by your eyes only, that yes, when we are boiling the water, so it's not like that whole of the water is going to be converted into vapor immediately. It's like some of the going to be converted and some is getting boiled. So that's how there would be the equilibrium at that condition also, that the amount of the vapors or the water is equal to each other, and that would be called as the liquid gas equilibrium, gas liquid equilibrium or liquid gas equilibrium. So that's the point when we are considering the liquid equilibrium over their physical phases or physical properties, that is called as the physical equilibrium. And they are of the different types, like solid liquid equilibrium, liquid gas equilibrium. There would be solid equilibrium also, solid gas equilibrium also. For example, a sublimation process. I hope you all know what is the sublimation process. In sublimation process, what happens, that solid directly convert into gases, and so that would be that gases directly convert into solid. So that's how, student, you can see that the physical equilibrium will be there between the solid and gas. For example, naphthalene balls, camphor. If we heat that camphor, so that camphor directly convert into the vapors. It will not convert into the liquid. Even though naphthalene balls are the same, that they directly convert into the vapors or in the gaseous form, there would be no any liquid state for that. So that's how the physical equilibrium will be there. When we are having equal amount of the two phases, then it will called as the physical equilibrium. Fine. I hope you got the what the physical equilibrium is. So till now, students, what we have studied about the like equilibrium, what's the equilibrium is. Then we have come to the point that what are the types of equilibrium. So the types of the equilibrium are physical equilibrium and the chemical equilibrium. And till now we have discussed only about the physical equilibrium, which we decide on the basis of their physical properties and on their physical phases. For example, like we have taken the example of water. Okay, so now moving ahead. For moving ahead, what I want is that we'll come to discuss about the chemical equilibrium. See, student, this chemical equilibrium, if equilibrium, sorry, it happens sometime equilibrium because it's a difficult word. Not exactly difficult, but yeah. So the thing is that chemical equilibrium is one of those topic when you are going to a class 11th, your 12th, even though in your high studies, if you are going to do something like that in your career related to chemistry, so chemical equilibrium will be there definitely. So it is one of the important topic of your studies. So it's like that if you are getting the knowledge about it right now, so it would be a very helpful thing for you. Okay, even though you'll get questions from it in your exams, in your olympiads, in your ntsc exams, or even though if I ask you for after 11th and 12th, when you done your schooling and when you go for your JEE exams and all of that, at that point you will get more advanced version of the equilibrium. Right now we are just discussing, or we are just getting the overview or some brief explanation about the equilibrium. Okay, so, like for a JEE, if I tell you, so first of all, your basics should be clear, na, that what's the equilibrium is, and what's the physical, and what's the chemical one. So that's how coming to the chemical equilibrium now. So, student, what's the chemical equilibrium is? Chemical equilibrium is the state, like the reactant and product example, which I was taking in the case of the reactions, like when I was discussing the reaction, when the concentration of both of them is equal to each other, then it is called as the chemical equilibrium. Okay, like the concentration of the reactant will be equal to the concentration of the product, then we'll say that the reaction is at the equilibrium. So if I read this statement, chemical equilibrium is the state in which both reactant and product are present in concentration which have no further tendency to change with time, so that there is no observable change in the properties of system. For example, like if it is also 5 moles, then it is also 5 moles, and at that point there would be no change can be happen at that reaction. So that is called as the chemical equilibrium. That means the equilibrium which we are getting on the basis of chemical reaction, that is reactant is converting into the product. So that's how we call it as the chemical equilibrium. Fine. Okay, so yeah, see, students, the thing is that we are having different type, like not exactly different type, but yes, there are many uses of chemical equilibrium in industrial processes also, or everything. But before that, I want to tell you some laws about it and this thing. Just a second. So yeah, it's a law of mass action which we studied under the chemical equilibrium. So initially you can see that A plus B is the product, oh, sorry, reactant side, and C plus D is the product side. So it's the reactant and product. Now initially what you are looking at, that the amount of the reactant is greater, whereas the amount of the product is less. So that means what I've told you in the initial, like very starting of the class, that when we do some reaction, so initially we have the more amount of product, more amount of reactant, but when we complete a reaction we have the more amount of product, because what we are doing, we are converting our reactants into the product when any of the reaction is going on. So we'll study what's the law of mass action in the case of equilibrium. Fine. But first of all, student, I want to tell you, like, I would like to tell you that there are the two types of the chemical equilibrium. One is the homogeneous one is the heterogeneous one. Okay, I'll tell you what it is. Okay, so coming to the, so if I ask you that what are the chemical equilibrium, so it's just that we have two types of it. One is the homogeneous one and another one is the heterogeneous one. So like in your class ninth, you are having one topic that is the solution, in which we have studied that what is the homogeneous and what is the heterogeneous. So do you have any idea that what's the difference between these two, homogeneous and heterogeneous? Homogeneous and heterogeneous. So, yes, students, the thing is that if we talk about homogeneous and heterogeneous, so homo means same. That means if anything, like something we are doing or something we are getting in reaction, so it would be same, like same. You say that what ma'am is saying. I'll give you example and then you come to know that what I am talking about. And hetero means different. Okay. So, for example, student, if I take one general example here, that A is gas, B is also gas, and it is converting into C, which is also gas. Now, in this condition, what you can observe, that the physical state of the product as well as the reactant, they all are same. That A is also in the gaseous form, B is also in gaseous form, and C is also in gaseous form. So that's how, student, the homogeneous reaction, we all, that the homogeneous chemical equilibrium says that when the equilibrium exists between the product and reactant, when both are having the similar state of matter or similar physical state, then it is called as the homogeneous. So that's why I'm saying it as the same, that at the product side and the reactant side, they all are present in the form of gas only. So that is how that is called as the homogeneous equilibrium. But if I talk about the heterogeneous, so if for example A is gas and B is liquid and C we are getting is the gas one. But now here what we can observe, that the physical state of the A is gas, whereas C is also gas. But if we talk about B is in the liquid state. So that's how there is the difference in their physical state, that all of the product and the reactant are not present in one particular physical state, they are different. So that's how it is called as the heterogeneous equilibrium. That means different. Hetero means different, I can say that. Okay, so that's the chemical equilibrium of two type, homogeneous and the heterogeneous. Fine, students. Now, coming to the law which I want to tell you. So, law of mass action. Now, student, what the law of mass action says. See, if please try to understand it. If A plus B is converting into C plus D, so it could be also possible, student, that that C plus that this reactant can, or like reactant is converting into the product, so there would be the condition that the product can also convert back into the reactant. For example, there is the one very famous decomposition reaction, that the calcium oxide reacting with the carbon dioxide converts into calcium carbonate, and even though calcium carbonate on decomposition converts into calcium oxide and carbon dioxide. So that's how they both condition would be there. So similar here it is. So students, in the rate of like law of mass action, what we observe, that if A plus B, that means this is considering the reaction in the forward direction and this reaction is converting in the backward direction. So if I consider the rate of the reaction, rate of forward reaction, so rate of forward reaction, I'm considering it as Kf. So it is always equal to the product of the concentration of the reactant side. Okay, so the rate of the forward reaction, that this Kf is equals to the concentration of the product of the concentration of both of the reactant. Okay, and if they are having any coefficient, for example A and B, I'm writing this reaction again. Just give me a second. Okay, that's how. So there it would be a raised to the power a and b raised to the power b. These are the coefficients, so you can write down in the writing down raised to the power. So this would be the forward reaction. That means rate of the forward reaction would be Kf is equals to, which is directly proportional to the product of the concentration of the reactant. Now the similar thing would be there, that the rate of the backward direction. That means when the reaction is going in the backward direction. So rate of backward reaction. So it's like I'm denoting it with the Kb, which is equals to the product of the concentration of both of the product. Okay, so it's like this. So it's the rate of the forward reaction, it is the rate of the backward reaction. So what the law of mass action says, that it says that the rate of the forward reaction or the rate of the backward reaction, what's the rate, student? That means at what condition or at what speed the reaction is going on to convert into the product, or at what condition or the rate the product is going to be converted into the reactant. And that's how we are getting the rate of the forward reaction and rate of the backward reaction. And for that I'm taking it as Kf and I'm taking it as Kb. So this is the condition. Fine. Now students, when we talk about the chemical equilibrium, so in chemical equilibrium what happened exactly is that these two, when the rate of the forward reaction and rate of the backward reaction will become equal to each other at the condition of the equilibrium. So it is that exact equilibrium which I want to tell you. So in the equilibrium what happens, student, that the rate of the forward direction is, like if I'm considering it as Rf and I'm considering it as Rb, so it just become equal to the Rb. So that it would be K, like so what happened from here, when Rf just become equal to the Rb, so it would be, student, that means when the rate of the forward reaction is equal to the rate of backward reaction, that means when the same amount of the product is converting into the reactant and the same amount of the reactant is converting into the product, then the condition is called as the equilibrium condition. And that's how they all are having the equal concentration. That's why we call it as the equilibrium. So that's how the rate can be written. And if I do that for the equilibrium, so what I can do is that the kb by kf is equals to kc. So this kc is called as the equilibrium constant. Equilibrium constant. And this Kc can, now you can imagine how we can write down it as, we can write down it as concentration of the reactant side divided by the concentration of the product side. So for example, for this reaction if I see, so the Kc can be written as, it's the product side, concentration of the product side raised to the power the coefficient. Okay, we have to write down the coefficient in the raised to the power form, and it's like a and it's b and b. So this is the equilibrium constant, that is we denote with the help of the Kc. That means when the rate of the forward reaction is equal to the rate of the backward reaction, that is the condition of the equilibrium, and that's how we get Kc. Kc is the equilibrium constant, and equilibrium constant is different for each and every reaction. It's not like that every reaction is having same equilibrium constant. It's like each and every reaction have different Kc, but the format of writing of the Kc is same for each and every reaction, whether it is the, whether we can say any reaction going to be there. Okay, so that's how we can write down the Kc. So now student, like what the thing which we are studying, it's the law of mass action. So what's the law of mass action? Says that the rate at which a substance reacts, it's directly proportional to its active mass, and the rate of chemical reaction is directly proportional to the product of active mass. So active mass of reactant and product, you can say that the concentration of the reactant and product. So that means when the rate of the reaction is directly proportional to the to rate of the reaction is directly proportional to their constants. So that's how we call it as. So we can see here that when the rate of the reaction is directly proportional to the concentration, so the product of the concentration, then we call it as this. So like Kf can be written as this, and the Kb is also written as this. So that is the rate of the forward reaction. How can we write down, students, here? So we can write down it in this format. So it would be Rf is equals to Kf into this, and I can write down it in the format like this. So it would be easier to understand for you. Okay, like Kb. So it's like Rf is equal to Rb, and now what I can do is that Rb divided by Rf, and that's how I'm getting Kb by Kf is equals to Kc. So that's the condition for the equilibrium concentration, when the rate of the reaction is directly proportional to their active masses. So these are the active masses of A and B, and this Rf is directly proportional to this. That means when the rate is increasing for the forward reaction, so it's the reactive mass is also increasing. So that's how the chemical equilibrium attains. Okay, and that's how we write down the equilibrium constant. So this is the law of mass action. Fine, students, I hope you all understand this thing. Okay, so this is the application which we'll discuss later. So first of all, I want to ask you that do you really get what the exactly the law of mass action is? So I'm repeating it once again. Law of mass action says that, see student, what happens that in our books and when we write in our exam, we have to use our standard definition. But from the concept of understanding something, it's like that the law of mass action says that when the rate of the reaction in the forward direction and in the backward direction attains equilibrium, means when they are having their direction like directly proportional to the concentration of reactant and product, means when the concentration of reactant and the product are equal to each other, then there would be the condition of the equilibrium, and in that equilibrium we get one equilibrium constant, which is equals to the concentration of product divided by the concentration of the reactant, and that's how we write down it. Okay, if I give one if I take one example for it, that how we exactly write down the equilibrium concentration. So one question I can discuss here: if 2hi plus I2. Okay, so how can we write down the Kc for it? So student, Kc is what? It is the equilibrium constant. It is always equals to the concentration of the product divided by the concentration of the reactant. So it's like concentration of the hydrogen, concentration of the iodine divided by the concentration of the Hi, which is in the reactant side, and raised to the power 2. Do you remember that if they are having any coefficient, so we have to write it into the raised to the power. So that's how we write down the Kc for any of the reaction. For example, student, we can consider any another question also. For example, N2 plus 3H2. Oh, sorry. Yes. 2NH3. See, student, right now I'm not considering the states. I just want you to understand that how we write down Kc. So again, if we write down Kc, so the Kc is equals to, first of all, the concentration of the product. This is product and this is reactant. So it would be NH3, and then it is raised to the power 2 because its coefficient is 2 here, divided by N2, concentration of N2, and that's how the H2 and raised to the power 3. So that's how students we write down the Kc. And even though in some condition like a question comes that find out the Kc, and they give you their concentration, like they can give you for example, concentration of hydrogen is 0.1, concentration of iodine is 0.1, concentration of HI is 0.1. So that's how what you have to do is you just have to replace by it only. That is 0.1, 0.1 divided by 0.1 whole square, and that's how you get the Kc value from there. I hope you got that how we can write down the Kc, that is the equilibrium constant. And see student, this equilibrium constant is why important for us. Like you'll say that ma'am, we are studying the acid base chapter and you just directly came to the equilibrium. So why we are studying equilibrium? So student, equilibrium constant can be written for the acid and bases also. How? For acids. See, if any acid, for example Ha, it converts into H ion and A negative ion. So if we write down the equilibrium constant for acid, so we use Ka. So we can say it is the dissociation constant of acid, because here acid is going to be dissociate into the ions, and that process is called as the dissociation. So we call it as the dissociation constant of acid, which we denote by Ka, dissociation constant of acid, which is similar to the Kc only, and we write it like the form of the Kc only, that is H ion, A negative ion divided by Ha. So this is the condition. And now if we talk about for bases, so for bases student, it's like that if we are having AOH, so it dissociates into A negative plus OH negative, because you remember na that acid gives H ions and the base gives OH negative ions, so same condition will be there. And Kb, now Kb we use for the dissociation constant of bases. I hope you are getting each and everything, my students. So it's like bases, and it is also equal, that is the A negative OH negative divided by AOH. And that's how we get Kb from here. That is the Kb, dissociation constant of acid, dissociation constant of bases. Now you will see that why we are requiring it, because when you are going to do the pH question for the weak acid, then you'll see that we require Ka or Kb for weak acid and weak bases. That's why the equilibrium concept must be clear to you. That means when initially the reaction started, we have only reactant, and the reaction completed, we have product only. But between that, we are having one point when the concentration of both of them is equal. So that's how we get the equilibrium condition. And for equilibrium condition, we write down one equilibrium constant. And if we are writing down that equilibrium constant for acid, so we use it as Ka. And if we write down that equilibrium constant for base, so we use Kb. Okay, and a similar thing will be there, that how we are writing it. Fine students, I hope you got the concept of the equilibrium. Now you will say, ma'am, okay, you got the, like we got the point that what's the equilibrium, okay, these are the type of equilibrium, physical, chemical, and that's how we write down equilibrium concentrations or something like that. But where we use this equilibrium, what's the actual use of it? So student, it's generally used in the what I can say in industrial techniques, like preparation of ammonia by Haber's process. For example, student, ammonia, that is the NH3 we get from the Haber's process. Okay, that means nitrogen and hydrogen react with each other and we get ammonia, and that ammonia is further used to make the fertilizers. Okay, or urea, something like that. We use that ammonia so that we get the fertilizer. So that chemical equilibrium used up there, we want more amount of ammonia. So what we'll do, that we'll do something like that, that the concentration of the ammonia will be formed, and that equilibrium is called as the chemical equilibrium. And the similar thing with the preparation of sulfuric acid by contact process. That means we prepare sulfuric acid from the sulfur dioxide, okay, in the presence of oxygen. So that's how we are getting the, and see the concept behind it, it's about the one principle is there which you'll learn in your higher classes. So for now it is important to you that okay, it is just for your knowledge. that where we use chemical equilibrium. But if we talk about that, what you have to understand right now, it's just that what's the equilibrium, what's the law of mass action, what's the physical chemical equilibrium, and how we write down Kc and Kc in the condition of acid, in the condition of bases. And see, student, yeah, I got one thing also, that if we talk about acids or bases, we are having two things: strong acids and weak acids. And I have already told you this thing, that the strong acid dissociates completely. That means we don't get any back ion, like any acid molecule as it is in it. Like if we are having 10 acetic acid, oh sorry, acetic acid is the weak one. If we are having 10 HCl molecules, so all of them are converting into 10 H positive ion and 10 Cl negative ion, because it is the strong acid. And in that condition, student, what happened, that the Ka is very, you can say that it is very high for the strong acids. Okay, but if we talk about the Ka, that is the dissociation constant of the weak acid. See, student, if we are taking the 10 molecules of acetic acid, that is the CH3COH, we are just getting only 2 moles of the H ions, or 3 moles of the H ions, or the 3 H ions. So that's how you can see that the dissociation of the weak acid is very less. So the weak acid, so the Ka we generally required for the weak acid, and the Kb is also generally required for the weak bases, because in that condition the dissociation is very less, whereas in the dissociation in the case of the strong acid, it is very high. So we don't require Ka for that, because it is having high value. But when we have to determine the pH of the weak acid, we require Ka. And how we require it, we look at in the next session. Because I hope in this session it would require you to understand the concept of equilibrium, at least that what's the equilibrium. And yes, please don't get confused about law of mass action. It just says that the rate of forward reaction will equal to the rate of backward reaction, and how that the rate of the forward reaction is directly proportional to the concentration of the reactant or the product, depending upon that which rate of reaction you are looking for. Okay, I hope you all understand the concept of the equilibrium. And even though if you have any of the doubt, any query in your mind, you can post your question over the public forum as well as the private forum, and you'll get your answer. And I hope you understand this concept of the equilibrium. And yeah, I haven't made you bored from this chapter, from this session. And thank you very much for watching my video. And yes, please keep learning from Ask IITians. Thank you, students.